Hello friends, welcome to GoodTecher LeetCode tutorial. Here we are going to solve container with the most water coding problem. So given n non-negative integers a1, a2 to an, where each represents a point at a coordinate point that's ai, horizontal value I, vertical value ai, n vertical lines are joined such that the two endpoints of line I is at point iai and point I0. Find two lines which together with the x-axis forms a container. Such the container contains the most water. Note here, you may not snap the container, and the n is at least 2. So when we first read this text of this coding problem, we may feel this confused. Like, what does this coding problem really means? What does this text information really indicate? What picture does this indicate? So we saw this. There are some important information like the x-axis, y-axis. So we know this is a graphic. There's an underlying graphic is indicated by this text information. So since it is a typical graphic coding problem, so we can first do a step to convert this text information to a graphic information. So we need to draw a picture from this text information. Since this coding problem doesn't provide any picture example, so we should do it by ourselves to convert this text information to a graphic information. Then we can generalize our ideas, our conclusion about the information, and then come up with a solution. So if we do that to convert this text information to a picture, to a graphic, it would be like this. So it would be like this. So on the horizontal line, that's I value, and vertical line, that's AI value. So as this coding problem indicates that, so like so any two endpoints. So if there's a line at this xy axis, that would be that there's a point I, ai at one endpoint, and on the other side there would be a I0. So they together build up a 9, that's a 9i. Also, as this coding problem indicates, so any two lines on this xy axis, which together with the x-axis, they come up together to form a container. So we see this, and so that like we take this first line and the last line, so they come up together with this x-axis, build a container. So a container holds the water. This is the amount of water a container can hold. So we can draw some conclusion from this picture. So that a container, the amount, the area is determined by this difference between the left and right lines. So that's right minus left. So since this is a rectangle, so as a coding problem indicates, you may not snap the container. So that we know this is a container that's a rectangle and container. So that we can perceive this right minus left is the width of this rectangle, and we should have a height so that we can get the area, and the height is a mean value of left height and right height. So why is that? Because we saw here that a container can host the most water. The height is determined by the smaller value between the left and right line. Otherwise, if this one is higher, and the water would like falling down. So that is determined by the shorter one, the shorter line. So for here, the left line is shorter, so the minimum would be the shorter one. So we know this conclusion that area is right minus left. So right index minus the left index, we get the width, and the multiply with the minimum value between the left height and the right height, we get the height, so that we get the area. So we know for each container, we can use this formula to get the area value. And for our goal is to find the area between two lines that can hold the max amount of water. So that max area. So max area is just the max value of all possible container area can be indicated from this picture. So like area, if we have like 3 area or even more, that's just max value we should do. So we see this picture. That's always we need to know that left line height, right line height. So we can think about this way. We can think about to use a very commonly used techniques for coding problem. That's 2 pointers. 2 pointers. So we can have a left pointer and a right pointer. Left start at the beginning, right start at the end. So for example, this is an input array. So input array is a height array of integers. That's each value indicates each line's height. Like first line is a line with a height 1, second one with a height with 2. So we can put our left point and right point. Left at the beginning, that's a 0 index, and the R is at the last one, that's a 3 index. And we can also have an area value and max area value. So air at the left, right, and right. So they will need to move in the middle direction, move to the middle direction. So at some point, they should meet with each other that's a terminal point. So while they are not meeting with each other, we should update their value so that we compare with a different area value. So like for the first time, so like air at the 0 index, R at the right index, that's 3. So for this one, the container area would be the right minus left. That's 3 multiplied by the mean value between left height and right height. That's 1 for this example. That's 3. And we will update the max value area. So we get 1 area. So far the max area is this value 3. And then so for at this time we know that our left line is shorter than the right line. So we can move the air line to the left line to the right, because we need to increase the height, because we know that the bottleneck for this container is the left line is too short. So we can move it right to see if we can get a bigger value for the left line, so that with a bigger to generate a bigger area value. So we move the left index to right. That's 1, and the R index still 3. At this point, so the right minus left, the width would be 3 minus 1. That would be 2 multiplied by the height. So the height for here, the minimum value, they are at the same value. That's just a 2 multiplied by 2. That's a 4. So 4 is greater than the previous max value, so we update the max value, that's a 4. And then for now, since they are at the same value, left line and right line, so we can move either one. So we can move the right one to the left, so we can move the right index to the left, so that would be the 2, and the left index still at 1. So at this point, this that's width is just 3 minus 2. That would be that's 2. Then 2 minus 1. That's 2 minus 1. That's a 1. That's a width. And multiplied by the height. Height would be the minimum value between the left and right. So that would be the still 2. So that's 2. And we compare with the max value. The max value is still the 4. And we move the L, since it is shorter, so we move the L to the right, and R is also at the right. So at this point, L pointer and the right pointer, left pointer and right pointer, they meet each other. So we know we finish this 2-pointer looping, iterating, so that we can use this max value. We know that we finish, and this is max value, max amount of water. This group of lines can hold the water. So we know that that's a final value. So you see this like an iterating process. With 2 pointers, we can get the most amount of water can be held by the 2 lines. So here, let's go back to the coding. So I'm going to demonstrate in Java to solve this problem. So first, we can have a variable that's as we indicates that max area. It can be started as with a 0 value, and we know it's also the final value we want to return for this problem. And first, we can have a edge case checks. So edge case check. So that if this input array is null, or if this input array, the length of this array is less than 2. Since like if there's a 0 line or just 1 line, it cannot build up a container, a rectangular container. We can directly with this return this max area that would be 0 at this point. And you see here, there's a no. You may not stand the container, and the n is at least 2. So the LeetCode indicates this n is at least 2. So this is optional, this condition. So we don't need to have that. The input array would always have at least two elements. So that's a optional one, but we shouldn't pay attention to that. And then we can have our 2-pointers technique. So left start with a 0 index, and right at the last elements of this array. So last index, that's a height.length minus 1. So while the left and the right, left is less than the right, they don't meet each other, we should do this. So before this, we can have integer called the area. That's an area, that's a local variable. That's just calculate the current left line and the right line, what's the amount of a container they build, the area. So that would be right minus left, that's a width, and the height would be the minimum value between height.left high, right, between the left high and the right high. And the max area we can compare to with the previous max area and this area. So if it is greater than the previous max area, we can update the max area. And if left height is less than shorter than the right height, we can increase the left pointer to the right. So we can increase the value to see if we can get a better, larger area. Otherwise, just move the right point to the left. And then that's it. So let's see a quick check about seeing if there's some typo or thing. So we first initiate with a max value, max area, and that's a final value we also want to return for this problem. And we do a edge case check. If that's null, and we directly return with a 0. And have 2 pointers. Left start with the first element, right start at the last element. When they don't meet with each other, we are doing calculation. Doing with the area, we can create the container water they can hold, like the width, multiply the height, and then compare with this area value with the previous max area value. And if the left height is smaller than the right height, we increase the left index. Otherwise, just make the right index smaller. Okay? Click submit. Accepted. So this is beautiful. So we have a correct code to solve this problem. So by introduce 2 pointers techniques that we successfully solve this container with the most water problem. The important step for this one is to convert this text information to a picture, and you know that what does this information indicate, and get the generalize the important formula to solve this problem. And also for this coding solution, if you want to analyze the time complexity, that would be, we saw this is just one single iteration, so that's just linear. So it's based on the size of this height input, and also for the space capacity. So we see here the local variables, those variables, their size is not determined by the size of this input array. So it's just a constant. They are being updated locally. So here it's a constant space capacity. Okay, that's all about this coding problem, container with most water. So thank you for your watching, and thank you for subscription to GoodTecher YouTube LeetCode channel. So hope you enjoy, and see you next time. Bye.